Lid's on. Ready to move it? Yeah, on three. 1, 2, 3. Paperwork's clear, you're good to go. Hoses are coiled, all set here.
The drilling rigs have left the site. The laboratory has completed all the soil tests. The geotechnical engineer has submitted the final report. So what's next? Do we immediately mobilize excavators and start construction? Not yet. Before a single bucket of soil is excavated, one important engineering decision must be made. Welcome back to the Tank Engineering Academy. In our previous lesson, we explored how geotechnical engineers investigate the soil using boreholes, standard penetration tests, cone penetration tests, laboratory testing, and groundwater measurements. Today, we'll discuss what happens after the soil investigation is complete. This is where engineering judgment begins. The project team gathers to review the geotechnical report because the next decision will determine the direction of the entire project. Reviewing the geotechnical report. Imagine you're sitting in the engineering review meeting. On the table are the soil investigation report, laboratory test results, foundation design criteria, and project specifications. The geotechnical engineer presents the findings. They explain the soil layers beneath the proposed tank location, the allowable bearing capacity, the estimated settlement, groundwater conditions, and any geotechnical risks that could affect the foundation. At this point, everyone in the room is waiting for the answer to one simple but critical question. Can the existing grounds safely support the storage tank? Everything that follows depends on the answer to that question. First possibility, the soil is suitable. Let's begin with the best case scenario. The geotechnical engineer confirms that the soil has adequate bearing capacity, the predicted settlement is within acceptable limits, and there are no significant concerns that would affect the tank's long-term performance.
Borings confirm dense sand throughout. Bearing capacity checks out. No ground improvement required.
Excellent. That simplifies the foundation design.
Exactly. We can proceed with the standard footings.
This is excellent news for the project. Because the ground is suitable, there is no need for costly soil remediation or delays caused by ground improvement works. The engineering team approves the site for construction. The project now moves to the next phase. Site clearing, surveying and layout, excavation, earthworks, compaction, foundation construction. Although the soil has been accepted, quality control remains essential throughout these activities to ensure the foundation is built exactly as designed. Second possibility, ground improvement is required. Now let's consider the second scenario. The geotechnical report identifies one or more problems. Perhaps the soil is too soft. Maybe the allowable bearing capacity is too low. The investigation may reveal excessive settlement, loose sand, high groundwater, organic material, or even a potential liquefaction risk. In this case, the project cannot proceed directly to foundation construction. The engineering team must first improve the ground.
The clay here is soft to 4 meters. For this tank, we recommend stone columns under the ring wall.
Depending on the site conditions, the geotechnical engineer may recommend one or more ground improvement methods. For shallow, weak soils, the unsuitable material may simply be removed and replaced with engineered fill. Loose granular soils may require mechanical or dynamic compaction. Soft, cohesive soils can be strengthened using lime or cement stabilization. Where greater improvement is needed, stone columns, vibro compaction, geotextiles, geogrids, or preloading with surcharge may be selected. Each method has the same objective: to create a stable foundation capable of safely supporting the storage tank throughout its design life. Verification. Ground improvement does not automatically mean the site is ready. The improved ground must be tested again. Additional field investigations may include standard penetration tests, cone penetration tests, plate load tests, field density tests, settlement monitoring. Only when the geotechnical engineer confirms that the required design criteria have been achieved can construction continue. Final engineering decision. Whether the existing soil was acceptable from the beginning or improved through remediation, both paths eventually arrive at the same destination. The site is approved. Construction can now begin. the contractor mobilizes heavy equipment, surveyors establish control points, earthworks commence, and the foundation construction phase officially starts. This marks the transition from geotechnical investigation to civil construction. The purpose of a soil investigation is not simply to collect data. Its real purpose is to support an engineering decision. If the ground is suitable, construction proceeds directly to site preparation. If the ground is unsuitable, engineers improve the soil and verify its performance before construction begins. Only after the ground has been accepted can a safe and reliable tank foundation be built. Remember this important principle. Every successful API 650 storage tank stands on ground that has been engineered, verified, and approved. Now that our site has been approved, whether naturally suitable or improved through remediation, we are ready to begin the next phase of the project. In Lesson 2C, we'll explore site preparation and earthworks, where we'll learn how engineers transform an approved site into a construction-ready foundation for an API 650 storage tank.